Hi, Algebra students. Hope everyone had a great weekend. So this is a brand new week. You have a test on Friday. So this video is not only to help you with your assignment on Tuesday, but it also serves as your study guide as well. So maybe you'll want to watch the video today and then maybe go back and look at it again on Thursday before you take your test on Friday. So let me bring up some problems that we're going to talk about. So for Tuesday's lesson, you're going to talk about correlation and causation. So these are two different things. They have some things in common, but a correlation, you can either have a positive correlation where two sets of numbers increase, or a negative correlation, which would be when one set of numbers increase and another set of numbers decrease. So positive correlation might be there might be a positive correlation between the number of hours that you study and test scores, right? So as the number of hours that you study increases, test scores increase. So there's probably a positive correlation between those two things. A negative correlation would be as the amount of hours you drive increases, the amount of gasoline in your tank decreases, right? So one set of numbers will always have to increase. Also, what about as the amount of time that you spend exercising increases, your weight decreases. So probably there's a negative correlation, though not always. Now, you can also have two sets of data that have nothing in common, right? That have no correlation. For example, if I said, how many books did you read last year? And what is the square footage of the house you live in? Well, probably one of those things has nothing to do with the other, right? So three things can happen with a correlation: positive, negative, or no correlation. Causation, however, is more like something that's been proven to be true through a scientific study, that we're not just guessing, and there's very few outliers, right? Correlations, we can have outliers very commonly, but causations would be very few outliers. So look at these questions. So do students that read more books have higher GPAs? Well, if we said that high GPAs is caused by people reading books, that wouldn't make any sense, right? But there might be a positive correlation between the people who read more books also have high GPAs, right? Maybe a positive correlation. Certainly lots of outliers would be there because not everyone that has high GPAs, grade point averages, ever read a book, right? Do people that eat later in the evening have higher body fat? So there may be a positive correlation between how late you eat and your body fat. But would you say that if you have a high body fat is caused by people eating late in the evening? No, I'm sure that has not been proven to be true. But there might be a positive correlation between those two things. Now, what about the third one? Does keeping food in a refrigerator keep it cold? Well, we would not own refrigerators if they didn't keep our food cold, right? So refrigerators cause our food to stay cold. So that is a causation. And we know that through research, through the history of having refrigerators. Does planting seeds produce vegetables? Well, the more seeds you plant, the more vegetables you would get. So not only is that a definite positive correlation, it's been proven to be true. If you want to have vegetables, fruits, you need to plant seeds, right? Because getting produce to grow is caused from planting the correct seeds. So that would be more causation. Now, as far as correlation, if we do have a positive or negative correlation, we can show that through equations. For example, when you make a scatter plot and you create that line of best fit, we can describe that line of best fit through an equation. We can show our data on an XY chart, and then we can take that XY chart and we can make a graph. So all three of those things can be used to show correlations. Causation, on the other hand, is harder to prove than correlation. Just because there's a strong correlation doesn't necessarily mean that we need to assume there's a causation. Causation is proven through controlled studies, scientifically proof. Things have been scientifically proven, right? So now everyone's aware that smoking cigarettes causes lung cancer. That's a causation. But, you know, in the 1930s, 1940s, 1950s, many more people smoked than smoke now, because even though people started thinking it was linked, it wasn't proven to be true until years later that people stop. They don't smoke as much as they used to. Because of this causation that's been proved, you must demonstrate cause and effect. Now, if you have, so last week in Ms. Gursky's video, I showed you guys, or she showed you how to find the correlation coefficient on your calculator. So hopefully you watched her video. If you didn't, you need to go back and watch it so you can figure out what a correlation coefficient would be. You know, usually we would always, I wouldn't ask you to find that by hand. You would either use a calculator, scientific calculator, graphing calculator, but these things are true. The correlation coefficient is always between -1 and 0. -1 means that you have a very strong negative correlation. Linear, if it's exactly -1, you have a linear. So you have a dot, 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 right in a row, right? 0, the closer a number is to 0 means, there's no correlation. And as you get closer to 0, you find less of a definite positive or definite negative correlation. And then a +1 would be a very strong positive correlation. A linear, for if it was a 1, but even like 0.95 would mean that you have a strong positive correlation. Now I put Delta Math on here because tomorrow you're going to do a Delta Math assignment. Now some of your choices are maybe above +1 or less than -1. So for example, if I said which of these shows a stronger positive correlation, and one of my choices was 0.89 and one of them was 1.03, well, you would probably think, well, this one's closer to 1, right? But you cannot have a correlation coefficient greater than 1. So this is not even an answer. This would be the answer, okay? So just because it's closer to 1, if it's more than 1, it's not gonna happen. So be careful when you answer those questions. You have been forewarned. All right, so let's look at this question because you'll have one pop up this week. When you go to the fair, you must pay a price to get in plus a price per ticket. The price, or the total amount of money you pay, can be modeled by the function y = 3x + 7. So what is the y-intercept and what does it represent? So the y-intercept is 0, 7, right? It's the number not being multiplied by x. And in this situation, what does it represent? Well, in this situation, it represents the price to get in, the price to get in, price to get into the fair, right? Because no matter if you buy tickets or not, everyone pays that $7 fee to get in. And then the question is, what is the slope? Well, the slope is the number multiplied by x, so the slope is 3. This is 2 questions, isn't it? And what does that 3 represent? It is the price per ticket. I feel very strongly you guys could all answer those questions, but I just wanted to go over them with you. All right, true or false? When there is a strong correlation between 2 sets of data, you can assume there is a causation. False, right? You should not assume there's causation, even if there's a strong positive correlation. And then let's look at this last situation. So this is kind of a step-by-step what you would do to test your hypothesis. You suspect that the spiciness of food served in a restaurant is positively correlated with the number of soft drinks ordered. So what would you do first? If that's what you think, what would you do first? Well, first you would observe people ordering food of different spice levels and the number of soft drinks they ordered. Then what would you do? Then you would take your data and you would plot that information on a graph, and then you would find the line of best fit. And then what would be your next step to test your hypothesis? To test your hypothesis. Well, in order to see how accurate your line of best fit is, you would then find the correlation coefficient to see how well the line of best fit describes your data. Okay, so that's the steps in which you would do this little experiment and figure out if your hypothesis is correct. All right, moving on. The table below shows the number of years after the year 2000 and the percentage of people of a country owning homes. So the question is, what is the correlation coefficient for the data? So like Ms. Gursky told you last week, we're going to use the data button on our calculator. We're going to enter in all of the X values in the first column. 1, 3, 7, 6. Then we're going to arrow right, and we're going to enter the percentages, 24, 32. We're in Y2, the second column, 36, 20, 28, 44, and 40. All right, then we're going to hit second data, 2 variables. We're going to enter 3 times. Whoops, I just messed up. I just messed mine up. 2 variables, enter, 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 and then we're going to go down and find capital D, little a. So capital D, little a is the slope. So I'm going to write the slope down here, or the equation. Y equals 4x, and our y-intercept is positive 16. And then my calculator tells me letter F, capital F, tells me that R equals positive 1. Positive 1. That means I have a very strong positive correlation between these 2 sets of data. So as the number of years has increased since 2000, the percentage of people owning homes has also increased. Oh, and that's what it says. It represents a perfectly linear positive correlation between X and Y. A 1 is as close you can get to that. All right, for Friday's test, make sure you can do the following things. Make sure you can construct and interpret a dot plot, a histogram, and a box plot. So if you need to go back to those sections and look at those, do so. Make sure you can identify an outlier and what it does to the mean. When describing the centers of data, should you use the mean or median when an outlier is present or when data is not symmetric? You would use the median, right? Make sure you can construct a 2-way table. And we're going to practice that in just a second. All right, so let's look at these, this information right here. We have some teams up here. We have 3 teams. It shows the low amount of cells, the highest cells of each team, the range of those cells, the average or the mean, the medians, the interquartile range, and then that little O with that little extra thing on the top means the standard deviation, which is very comparable to the mean absolute deviation. So the standard deviation just shows us how close each data item is from the mean. So how far off each of them can be. So just like with mean absolute deviation, the smaller the standard deviation, the less varied your data is. Okay, the bigger that number, the more varied your data is. A boss is trying to award deserving sales teams. If the boss was to give an award to the team with the most consistent sales, which team should he choose and why? So for consistency, we're looking for a small range. We're looking for a small interquartile range. That's the middle 50% of your data, how spread out it is, and a small standard deviation. So which team has the smallest of those 3? Well, it looks like Team Y has the smallest range overall, the smallest interquartile range between the middle 50% of his data, and the smallest standard deviation, which means that Team Y has the most consistent sales, and it would be to justify my answer, I would mention everything I just said. All right, what about if he wants to award the team with the highest average earnings? Highest average earnings, which team would he choose and why? Well, we're going to obviously look at the high sales, but we also want to probably look at the highest average and make sure that this isn't just an outlier. And one of the ways we could tell if it's an outlier is that we would look at the range and say, okay, how far apart is the lowest and highest numbers? Well, this is a lot smaller than this, isn't it? So these numbers are much more varied. These are closer together, quite a bit closer together, and it's so much bigger than this one that I would say that Team Z definitely has the highest average earnings, right? Since this is not as varied, this mean would be, we could depend on the mean, right? Because it shows that Team Z doesn't have a big varied data. It is a lot more consistent than Team Z. No, Team X, excuse me. So the answer is Team Z. And I would talk about it has the highest mean, it has the highest average, or not that it has the highest not range, but the highest earnings. Just the highest by itself is significant, but also it's got the highest average earnings. So that would be a good way for me to justify my answer. All right, is there a correlation between the number of employees and the number of products produced? Well, once again, I'm going to use my calculator. I'm going to figure out what the equation is, the line of best fit. I mean, I could make a what's it called? Scatter plot. I would count my x-axis by tens all the way up to 80. I would probably count by hundreds over here on my y-axis all the way up to 800. I would plot all these points. So if I hadn't shown you how to use your calculator, this would probably be the way you would want to do this, right? All the way up to like 800. Plot those points. But like I said, we can just use our data button. So we're going to hit clear and on to clear it. Then we're going to do our data button. We're going to enter our X values first. Then we're going to right arrow and go to L2, and we're going to enter those values. 280, 360. And then we're going to do second data, 2 variables, enter, 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 go down to capital D. And I'm showing that our line of best fit equation is 8x plus 120. So my R is +1. Well, +1 is the highest I can get for a positive correlation, right? So we could definitely say there's a positive correlation between the number of employees and the number of products. So write an equation. Well, we've already done that, 8x plus 20. And what does the slope and y-intercept mean? Let me get rid of my little sketch of a scatter plot. All right, so the slope is 120. Excuse me, it is not. So the slope is 8. And what does it represent? It represents the number of products per employee. So every time the number of employees increases by 1, the number of products increase by 8. So 1 to 8, 1, 8, 1, 8. And then what does the y-intercept indicate? Well, that is, the y-intercept is always our initial amount, right? So it's we had an initial amount of 120 products. So before we started adding more employees, we were maybe producing 120 products. And then as we started increasing our number of employees, our products continue to increase by 8 for every employee that we added. So it's our starting place, right? Our y-intercept. All right, here is a scenario about 2 types of dances, learning salsa and learning ballet. So a dance school has 54 students who learn salsa, and 23 of those students also learn ballet. All right, so we have how many total students learning salsa? We have 53. Now, this tells us to make a conditional relative frequency, but in order to figure out what my percentages are going to be, I have to write my totals somewhere, right? So of these 54 students, 23 also learn ballet. So 23 goes here. They learn both. 15 do not learn salsa, but learn ballet. So no salsa, but ballet is 15. And then we have 10 that do neither. So no salsa, no ballet right here, 10. Now we're doing, like I said, conditional relative frequency. So if you notice, these are already ones. So that means this column, not a column, but a row, this row has to equal 100%. This is going to equal 100%. And our total number of students involved completely is 100%. So first of all, I want to know how many total students we're talking about. Well, this is 53 that learn salsa. The ones that don't learn salsa, there's 25 of them. So that tells me that we have a total of 78 students. So 78 students is equal to 100%. So what percent of those 78 learn salsa? Well, then we're going to divide 53 by 78, and that would be, let's see, 53 divided by, oops, I didn't clear my table. 53 divided by 78 is 0.68. So 0.68, and 25 out of 78 is 0.32. Well, there's our 100%, isn't it? 68% and 32%. And that's where we're getting our 100%. So there, our rows are going to go this way. All right, well, what would be this total? The ones that learn ballet, 23 plus 15 would be 38. So 38 represents 100%. So we need to figure out 23 out of 38 is what? 23 out of 38 is 61. So this is 0.61. And then we could just subtract 61 from 100, or I can double check it and say 15 divided by, is that 15? Yeah, 15 divided by 38 is 0.39. And then what would be this number? Let's see, if this was 23 and this was 53, this would have to be 30, right? 30? And so 30 plus 10 is 40. So 40 represents 100% of this column or this row that did not learn ballet. So 30 out of 40, that doesn't seem right. Did I miss something? No, not 30. Yeah, 30, I guess, right? Did I get my numbers right? I got 54. Oh, I put 50. You guys, I put 53 this whole time. This is a 4. All right, so this is a 1, this is a 31, and this is a 41. I'm sorry. Y'all are probably like, Miss Richardson, that's not a 53, it's a 54. You've probably been saying that the whole time, right? All right, so what's 31 out of 41? 31 out of 41 is 0.76. 0.76. Now, this is obviously going down. It's not going to equal 100%, but having this 1 over here on the right helped us figure out where our 100% had to add up to be, right? So then 10 out of 41 is 23%. 23%, okay? So that's kind of what we're looking for as far as our choices. So these were the choices I saw. And it looks like, yep, the one in green. The one in green agrees with our numbers. So you kind of have to sketch your own two-way table to get these right. I mean, it's hard to do all of that in your head and keep it all straight. You need to sketch your own two-way table. All right, this one is asking us, look at the bottom, the sum of the residuals. So it says an equation was used to predict possible sales of phones for 6 months. The actual sales of phones are listed. So if we want to find the sum of the residuals, that means we have to figure out how much were we off by. So if we predicted 40, but the actual sales was 15, the difference in 55, then that means the difference between 55 and 40 is 15, right? So our actual sales were 50 and our predicted sales were 50. So what was the difference? That one was spot on. Actual 325, predicted 300 for a difference of 25. Here we had a difference of 10. Here we had a difference of negative 20, and here we had a difference of negative 10. All right, so our 0 is gone. So now we're doing a sum of those residuals. So negative 10 and positive 10 cancel. So 25 plus 15 is 40, and the difference of 40 and negative 20 is positive 20. So that's how you do that. Oh, yeah, we got it right. Good. All right, and now let's look at this one. Is this the last one? No, we got a couple more. All right, what does this say? A scatter plot is made to model the number of grams of fat in different portions of fried shrimp. The data used for the scatter plot are shown in the table below. So we got to figure out a slope. So in other words, we got to use our data button, and we're going to use the line of best fit. If this were a scatter plot, we could certainly make a scatter plot. I'm going to input all my data into that two-way table, or excuse me, that T-chart on the calculator using the data button. I got it all in. Now I'm doing second data, 2 variables, enter, enter, enter. And now I'm going down to find capital D. All right, it tells me my equation is y equals 9x plus 0, which obviously I could have, if I looked at this for more in a second, I would have said, okay, 9 times 5 is 45, 9 times 3 is 27, so on and so forth. So what does the slope mean? So the slope means is the number of grams of fat, what? Per portion. It's the number of grams of fat per portion. Oh, yep, that's what we said. Okay, what about this? It says, consider the following scenario. A football player notices a pattern in the points he scored per game last season. Which event probably has the strongest correlation with the football player's points? Now, you got to think about what it's asking you to find a correlation between. So how does a football player earn points? Well, he either is the kicker, right? Or what's the only other way? He scores touchdowns, right? So would there be a positive correlation between his points and the average high temperature on game day? The number of times he caught a pass successfully? The number of hot dogs sold during each game? Or the color of the opposing team's jerseys? So we could definitely get rid of 3 of those, which means that there's the strongest positive correlation between his points has to do with the number of times he caught a pass successfully, right? So the more he catches successful passes, the more touchdowns he can make. Very good. All right. So just make sure you think about what it's trying to make a positive correlation between. The weather probably didn't have a lot to do with it. Hot dogs sold during the game, no. The color, definitely not. But how many times they caught a successful pass? Yes, that makes sense, doesn't it? All right, you guys. So hopefully that helped you. Make sure you take your test on Friday. I'm going to be out of the office on Friday, but up until Friday, I'll be here for you. We have my brother's having surgery on Friday, so I won't be available on Friday, but I can help you up through then. And I hope everyone has a great week. If you need my help, please let me know.